So homework, we have no homework to go over, so we're gonna look at notes, ratios and proportions. This should be review mostly from middle school. You've seen this stuff before. Okay, so we are on 2-6, ratios and proportions. Okay, what do we know about ratios and proportions? You know something, you did it in middle school. Ratio. Guys, stop talking, please. Tell me what you know about ratios and proportions.
Ratio is always. Oh, I remember what it says. I can't remember. I know what it is. I can't remember. Ratio is like 2 to 1.
2 to 1, yeah, ratio. That's one way to write a ratio. 2 to 1.
1 to 2.
Or 1 to 2. So you can do 2 to 1. You can actually write out the word 2. How else can I represent a ratio? Sheldon?
2 with like the semicolon thingies?
Yep. 2 to 1 like that. Or I can write it as a fraction, 2 over 1. A fraction is how we see ratios written probably most often. Just FYI. But you can also see it as the other two ways. All a ratio is we are comparing two things. So when we talk about ratios and story problems, we're looking at comparing two things. Now a proportion is taking it one step further. Proportion is what? Yep, two ratios that are equal. Two ratios that are equal. Okay? So you've seen this before, so it should be pretty good for you. Just a short lesson. Example 1, determine whether each pair of ratios, these are not proportions, they are not equal to each other, they are just ratios. So determine whether each pair of ratios are equivalent ratios. Write yes or no, justify your answers. Okay, fancy math word, equivalent means what? Equal. So I want to know, are these ratios the same? We kind of talked about this when we talked about fractions. And I want to write yes or no and explain. So as I look at A, how could I tell? I have 7/8 and 49/56. How can I tell whether these are equivalent or the same ratios?
Would you simplify?
Yes, simplify. Simplify it down and see if they come out to be the same fraction or same ratio. 7/8 we can't simplify. 49 over 56. How can I simplify like we've done before? 49 over 56. Divide top and bottom by 7. 49 divided by 7 is 7. 56 divided by 7 is 8. They are equal. 7/8 is equal to 7/8. So yes, they are equivalent ratios. So we are simplifying down to where I can compare them and see if they are equal. Let's look at B, 6/10 and 2/5. Okay, 2/5 I can't simplify, so that just stays 2/5. How can I simplify 6/10? Divide top and bottom by 2, which will give me 3/5. 3/5 does not equal 2/5, so no. And when it says justify your answer, all I care about is that I see work. So this would be fine. You don't have to write it out in complete sentences. This would be fine for justify your answer. Any questions on that? Can we do that? We good? Yeah? Okay. Example 2, I don't know why I chopped it off. Use cross products to determine whether each pair of ratios form a proportion. So as I look at, so it's the top of the next page, sorry, I kind of chopped it up. I want to see whether these two ratios form a proportion. A proportion, the cross products have to be equal. So when I think about proportions, the cross product have to be equal to each other for it to be a proportion. So as I look at figuring out if these are proportions, I'm going to take the cross product. Product means what? Multiply. I'm going to take the cross product and see if they are equal. So 0.2 times 0.9 and I want to see, is that equal to the other cross product? So is that equal, so I'm going to put a question mark over it, is that equal to, what would the other cross product be? 1.8 times 1, which would just be 1.8. Okay, grab a calculator if you don't have one. So for it to be a proportion, the cross products have to be equal to each other. Okay. You probably wouldn't need a calculator. 0.2 times 0.9.
0.18.
What is it?
0.18.
0.18. 0.2 times 0.9. 0.18. Does that equal 1.8? No. So the cross product is not equal, so it is not a proportion. For it to be a proportion, the cross product has to be equal. And then let's check part B. Cross product, first cross product would be what? Yep, 2 times 20. Is that equal to, I'm going to put a question mark, is that equal to 2.5 times 16? You don't need a calculator. 2 times 20?
40.
Does that equal, what's 2.5 times 16?
40.
40. That does equal? So yes. So for a ratio, for two ratios to be a proportion, their cross products have to be equal to each other. Which leads us into the next area. What if I tell you it's a proportion? So now I'm going to solve a proportion. I know they are a proportion. So if something is a proportion, what do I know about their cross products? They are equal to. Proportions, their cross products have to be equal to each other. So now they tell me their proportions. So now I know the cross products are equal to each other. I want to solve. If I'm solving, what's my answer going to look like? Anytime you have the direction solve.
Answer.
Thank you. A little more specific than that. Anytime, we've done it for the past 2 weeks. Anytime it says solve this equation, what will my answer look like? No. We've talked about this lots of times. Go back and look at your notes if you need it. I'm not going to answer this question for you. If the directions say solve, what will my answer look like? We've solved numerous equations the past 2 weeks. What's your answers always look like? X equals a number. Yeah, we're trying to get x equal a number. It's the same process as when we did normal equations. A variable equal to a number. I want to know what number does that variable represent. So if it's a proportion, we're going to cross multiply, because proportions, they're cross products. So cross multiply, and we're going to set each product equal. That's the definition of a proportion. The cross products are equal. So I'm going to cross multiply, set each product equal, and then you're going to solve like a normal equation. You've seen these before. So you have, just like with absolute value equations, you had to do something a little different, and then you got to a normal equation. Same thing here. After you cross multiply, you have a normal equation that you know how to solve. So example 3, I have a fraction equal to a fraction, a ratio equal to a ratio. It's a proportion. the cross products of proportions are always equal. So we're going to cross multiply, set it equal to each other. If I start with the top left, x times 5 will give me what? 5x equal to 3 times 10, which is 30. So cross multiply and set your products equal. And now we have an equation we know how to solve. How do I solve it? Divide by 5, so x equals 6. As I look at B, what's different about B?
There's an equation.
There's not an equation, there's a what? What's that x plus 4? What do we refer to that x plus 4 as? And a what? What did I call something that had a variable, an operation, and a number? From chapter 1. What did I call something that had a number? So x plus 4 has a variable, an operation, and a number. What do we call that? Expression. So we have an expression as a numerator on the top of the first ratio, or the first fraction. Do the same thing. We're going to cross multiply. When I cross multiply, though, how am I going to have to set that up? X plus 4 times 4.
4x plus 16.
Okay, we're going to set it up like this first. We have to put x plus 4 in parentheses. So 4 times x plus 4, because x plus 4 goes together. Equals, when I cross multiply the other way, I'm going to get what? Is that 12? Yeah, 12 times 3, 36. So if you have an expression or a binomial, because there's two terms, don't get too worried about that, you have to set up distributing, parentheses. Now, let's distribute, which David already did, but let's go ahead and distribute. 4 times x, 4 times 4, plus 16 equals 36. Now it's an equation you know how to solve. We are getting it to a point where you have an equation that you know how to solve from last week or the week before. What do I do next to solve this? Subtract 16, subtract 16. 4x is equal to, divide by 4, x equals 5. Any questions so far? Okay, let's look at C. Just a couple more examples. We're not taking many notes today. Let's look at C. If I set up my cross product, this is a proportion. It's a fraction equal to a fraction. So let's set up my cross product. If I set up my cross product, it's going to look like what? 7 times equals, do it. Yeah, 2 times 14, which is 28. So if I cross multiply, 7 times x minus 2 equals 14 times 2, which is 28. Now we have a normal equation. What do I do first? Distribute. What am I going to get when I distribute the 7? Minus 14. Good. So 7x minus 14 equals 28. What do I do next? Add 14. Add 14. 7x equals 28 plus 14. 42. Divide by 7. X equals 6. Now, any equation you can always check. So just up here in the corner, we can always check it just like an equation. Plug 6 back in where x is. 6 minus 2 over 14 should equal 2/7. So you can always plug it in to check it. What is 6 minus 2? Does 4 over 14 reduce to 2/7?
Yes.
Yes. So you can always, any equation, you can always plug it in to check it. No matter if it's proportion or if it's distributing or whatever. You can always plug it in. Any questions on those? They look familiar? Like you've seen this before?
Probably the first part of it.
Yeah.
Have you seen the second part too?
You've done this in middle school, I think.
Oh, yeah.
Yeah, okay. I think so, yeah. Okay, let's look at a couple story problems. So the gear on a bicycle is 825. This means that for every 8 turns of the pedals, the wheel turns 5 times. Suppose the bicycle wheel turns 2,435 times during a trip. How many times would you have to crank the pedal during the trip? Story problem. What do I do first? See what they're asking for. What are they asking for? How many times you will have to crank the pedal? That is going to be my variable, C, for crank the pedal, I guess. So whatever they're asking for is 95% of the time going to be your variable. Now, I need to set up an equation so I can find out what C is, so I can solve for C. As I read this, what information do they give me?
How many cranks the pedal takes to get the wheel to turn 5 times?
You have it switched. Oh, you're right. Yeah, I read it wrong. Yeah, so it takes 8 turns of the pedals for the wheel to turn 5 times. They give me a ratio, 8 to 5. So how can I represent that ratio? 8 over 5. Yeah. They give me the ratio 8/5. A ratio is comparing 2 things. In this case, we're comparing the turns of the pedal, 8 turns of the pedal, to the turns of the wheel, 5 times. So 8 to 5. Now, as I look at my proportion, as I set up a proportion, you have to keep the numerator and denominator the same. So what does 8 represent? Turns of the pedal. So if 8 represent turns of the pedal, if the numerator of the first ratio is the turns of the pedal, what represents the turns of the pedal? C. So C has to go on top. You have to keep it consistent. If the first ratio, 8, was the turns of the pedal, then you have to put C, which represents how many times to crank the pedals. That has to go on top as well. On the bottom, 5 represents how many times the wheel turns. And then what do they tell me about? I want to know how many times I turn the pedal. No.
Yep, 2,435. You have to keep it consistent. So if the top is the turns of the pedal, that has to be for both ratios. If the bottom is how many times the wheel turns, that has to be that ratio. Okay, so I have a proportion, cross multiply. I'll do it to the side here. 8 times 2,435 is going to be equal to what? 5C. Okay, I don't know that off the top of my head. 8 times 2,435?
19,480.
19,480 equals 5C. Divide by C, which,
396.
yep, 3,896. And that is cranks. Equals C. So make sure you label it, whatever it's representing. Now, that's how many times I have to crank the pedal or turn the pedal. Yeah, does it make sense? I guess. It's hard to think about it making sense, but I'm not going to get a negative. Probably not going to get a decimal. You can't really turn it half. I guess you could turn it half a crank, I guess. But okay, any questions on that one? Okay, let's look at the second one, and last example today. Example 5. On a road atlas, the scale for the map of Connecticut is 5 inches to 41 miles. What is the distance in miles represented by 2.5 inches on the map? What am I looking for first? Distance in miles. So good variable would be M. Or D, whatever, I don't really care. So I want to know what is the distance in miles. That's my variable. As I read, what information do they tell me? 5 inches to 41 miles. It's my ratio, 5 inches to 41 miles. I need to keep it consistent. It's 5 inches to 41 miles. So as I look at my second ratio, how many inches do I have?
2.5.
So 2.5, you have to keep it consistent. It was 5 inches to 41 miles, so my inches have to go on top. And the miles is what I'm trying to figure out, so that goes in the denominator. Cross multiply 5m equals 41 times 2.5. You don't have to show this like actually writing out the multiplication. You can just do it on your calculator. What is 41 times 2.5? 102.5. Divide by 5. 102.5 divided by 5? 20.5 miles. Why does that make sense?
Because it's half of 41.
Yeah, if 5 inches were 41 miles, 2.5 inches is half of 5, so we're expecting the miles to be half of 41, which is 20.5. Okay. We feel okay with this stuff? Yes? Okay, I think you guys get it pretty well in middle school, but we're just reviewing it. Okay, so if you're like, I struggle with ratios, keep your notes out. Otherwise, you can put them away. And then let me pass out this. You'll have time to work on homework later. After you get finished with this.
What are we doing another activity?
We're doing the actual going back to the sugar stuff.
I see.